So welcome you all to the post-tea session on day 2 on the afternoon session. Online participants, please confirm whether you are getting my voice and able to see the computer screen.
Yes, sir.
Okay, fine. So now we will discuss about the structure of a original research article, what it should contain. So as we have already discussed, the nature of work can be purely experimental. So I request all the participants, please keep your mic in mute mode. It can be a purely experimental work. It can be purely numerical work. It can be pure analytical work. Or it can be a mix of above three. That means it can be experimental and numerical, experimental and analytical, numerical and analytical, or experimental, numerical and analytical. Clear? So I call this to be only experimental, only numerical, only analytical, or a combination of two or all three. So 1, 2, 3, 4, 5, 6, 7. So 7 possibilities are there. And the 8th one, what will be the 8th one? It will be a purely review article. So it will be neither be called experimental, numerical or analytical. It will be a review article, but all are journal articles. Okay. So already I have explained you for review article, there is no fixed content criteria. You are free to decide what to write and how to write. Just to observe more and more review articles, you see how they presented, and from there you use your thought process and you write it. But do not try to copy a particular one. Clear? Okay, so here I will show you a few articles which involve experimental, numerical and analytical, and you can understand if your work is purely experimental, how to write, purely numerical, how to write, purely analytical, how to write, or in a combination, how to write. How to write means whatever to be a order and what content you will include there. For example, this is a my first publication out of my MTech work. It is a purely analytical work, 100%. That means it contains only mathematics. So what it says heat conduction in a heat exchanger tube, and the tube cross section is non-circular in nature. So normally tube means there will be two circles, one circle inside another circle. The two circles, the center coincides. The center coincides. That is called a circular tube. And here it is non-circular in nature. Either inner or outer or both will be non-circular here. So it is purely analytical one. So you see what are the contents here. You can see this is your abstract. And here you have the keywords. Then here you have your introduction. As I told you, introduction includes brief introduction. You can see here this part is brief introduction. After that your literature review starts, but literature review you will not write as a separate heading. So how to know literature review starts? You see here the numbers are given here. Number means these are the references to different things. Okay, so here you see it says, if I try to read it, mainly two types of non-circular shape, elliptical, lenticular, have been considered, studied, ... and have been taken up by a number of researchers. That means serial number 1 to 4, these 4 papers have reported elliptical, lenticular type pipes. That is what I want to mean here. So here it will be a literature review, and when you go in the literature review, finally towards end you will conclude that whatever your work you have reported here is not reported in the open literature. That's why you are doing here. That should be the conclusion of the literature review. So here you see, though so here what is done here, it is explained here. And since it is a purely numerical work, means purely mathematical in nature, so next section it writes here what is the boundary condition, because mathematical means it involves boundary condition and the solution. So boundary conditions we have explained here, then the solution, that is known as the mathematical formulation. So we have given the heading mathematical formulation. It starts with the governing differential equation in dimensionless form, then applying the boundary conditions, then we have tried to solve this one here. So whatever you see, it will just look like purely mathematics only, because it is analytical means purely maths only. And these are the shapes we considered, which are not circular in nature. Okay, so you can see here the names given here for these shapes are oval, lenticular, and teardrop. If I write only oval, people, I do not know how they will mean, because I mean this to be oval. The reader may mean something else. So that's why, to avoid confusion between the writer and the reader, along with writing it to be oval, I have also given the photograph, a figure given, so that I am telling that this shape I am calling as oval. So reader will understand this is the oval. That's why instead of only writing set up the tube as only oval, I have given also a figure here. So here you see, this gives a better communication to the reader. And this table, I used my own concept, and I thought that this information should be in a tabular form. So accordingly, I created this table. And please observe here, in the table, no horizontal vertical lines are not there. All these horizontal vertical lines are not there. Only what you see, horizontal lines. At extreme bottom, you will have one line, and for the headings, you will have upper and lower line. So only three lines will be there. For heading, upper line, lower line, and at the bottom, one line. So this is the standard, and internal grids will not be given in a table. Always, this is a thumb rule. You should note down it. So you create the table, then you hide them. Okay, then your mathematics is there. Then I try to explain the mathematics through this analysis here. I take this section and I did the analysis here. Heat coming in, heat going on, dot, 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 dot. So here I adapted 2-3 different methods. So for another method, I assume this to be sliced into small pieces, and I did analysis for individual pieces. Okay. So this is a second method. That's why sector method. That name I've given. Software you require. Software you require. And writing mathematics also, you need some equations. Software required. Of course, inbuilt feature is there in the Microsoft Word, but there is a dedicated software is there called math type. So I personally prefer to use the software math type instead of inbuilt feature of Microsoft Office to write equations. Whoever interested can note down the name math type. You do in Google, you will get the software, but software is not free. Okay. So this is your mathematical part. So analysis completed, then comes your results and discussion part. So after that, you get your results and discussion. So you try to remember that formula we have written earlier. So can somebody read the formula? I've written a structure of the paper. Whatever written, please read that.
IMRAD.
IMRAD, IMRAD, introduction, main body, result and discussion. So you see here, it starts with introduction. M is the main body. Main body can be anything depending on your situation. Here main body is boundary condition, mathematical formulation for this method, and I am using another method, sector method. So it is your M method. Okay, I for introduction, M for method. Then comes RAD, result and discussion. So here comes your result and discussion. Under result and discussion, you can have subheadings as per your need, like temperature distribution I am explaining, so it is written temperature distribution. Then you will get some second heading, efficiency. So I have given another heading like that. After that comes your last one is your conclusion. After conclusion, you have one section called nomenclature. Nomenclature is nothing but writing the symbols, their meanings. Okay, otherwise people will find it difficult to name. Some journals write the nomenclature at the end, some journals write the nomenclature at the first. Okay, so it will be given there, accordingly you write it, nomenclature. After the nomenclature, you have your references. Clear? So this is the structure. So here you see it is a purely mathematical paper. So you understand method means your mathematical methods. Whatever mathematics was there, that you have used here. Now we will take another paper. Let's say we will take a one. Okay, this is also another analytical paper only, mathematical paper. So here you see again abstract, then introduction starts. Here you see nomenclature is the start because it is another journal. So nomenclature is at the start. Okay. Then comes your mathematical formulation. So it is your method. Under method is mathematical formulation. So it's only maths only. Okay. So it is part of method only. Estimating transport coefficient, part of maths only. Then comes your result and discussion. So result and discussion, you will have the graphs. So graphs will come in the section of result and discussion. Okay. Then comes your summary and conclusion. Then here it is acknowledgement. Acknowledgement is not mandatory because nobody helped to whom you will acknowledge. Clear? So that paper did not have acknowledgement. Here we have acknowledgement. Then as you told us, appendix. So here you have appendix. So here there was a requirement to introduce appendix. So somewhere it is given for details, see appendix. So this is the appendix here. Calculating the area. So I did not put there because that will break the continuity of the information there. After that, you get the references. Okay, so this is analytical paper, and then you will. Okay, so this work is a mix of experiment and simulation. This work is a mix of experiment and simulation. So the rule is same, IMRAD only. So only M, your content will change. So here it starts with again abstract. Here keywords here. It starts your introduction. Introduction contains your references. It starts your literature review section from here. Then your nomenclature. Here this journal wants at the top. So always nomenclature they will put on the second page when it is top, not on the first page. Okay. Then you see here I've given a separate section as a literature review. It is not mandatory. You can give or you cannot give. It is not a fixed rule. So I've given separate section. Okay. So when people give separate section, when the review is exhaustive, that means little bit more. When the review is little bit small, you make it part of introduction only. Okay. So you see, it is exhaustive literature review. Actually, earlier the culture was like that. You give more stress to review. Nowadays, the culture is less stress to review. But you cover important paper briefly only. Okay. So here you see, after end of the last paragraph review, how you will write is you can see here. We summarize the review here. In summary, experimental investigation thus the dot have been focused in these areas. But here you can see here, these studies reveal contradictory conclusion. Literature says different conclusion, contradictory. That means clarity is not there. So this requires further study to make the concept clear, which is the motivation for the study. That's why we studied it. So without motivation, then the reviewer will ask why you did this work. So this is the motivation. That's why you did this work. You have to explain. Okay. So there is a need of systematic data analysis and its careful scrutiny for scientific ... That's why only we did this work. And what we did, that also briefly we will write it here. Okay. Then comes your, as I told you, this is experimental work. So this is your M. Okay, this is the M. M contains here, since it is experimental plus simulation, here first is experimental details and procedure. What it will contain? Here you will give all details of the experiment, the maximum possible. So here you see, normally people will give one experimental photograph. So here you given this actual photograph of the channel. Then to make it better understand its schematic view and how the experiment was working, that is explained through this diagram. Okay, and here if you read it properly, very minute details will given. What is the brand of thermocouple used? What is the brand of this instrument used? Brand of that instrument used? The more branded instrument you will report, they will have more confidence in your work. Suppose I measured pressure using Honeywell pressure gauge. Honeywell is an international brand. So people will believe that the pressure data is accurate. Otherwise, you will tell the name of some brand which is known only in Rourkela or around surrounding only, local brand. So nobody will believe that data. That's why if you are going to do experimental work, always you should make a habit or mindset to purchase only branded very good items. Like when you want to purchase a TV for your own, whether you want to purchase a branded TV or a just like any unbranded TV. So obviously for our personal use we go for a branded one. Here also for research also you should go for branded ones. So you can see here minute details will be given. Depth of the channel measured with a high precision linear encoder. Fagor brand is there. Fagor. Okay. Optical microscope Leica brand is given. Very reputed. And when you purchase, you can ask, sir, how to know which is branded? You read the previous paper. That will give you for microscope which one to purchase, for pressure transducer which one to purchase, model number will be given. Your work will be similar to them. From there you get the idea. Okay, iske liye, I can purchase this one from this one from this, like that. All branded you see here. Electrical heater, mica insulated, Mac Minco is given. A model number is also given. Okay, DC supply Microtech is given. Constant temperature bath Hakka is given. So every minute detail you will give. The more detail you will give, they will have more confidence in your work. If you are trying to hide means, they will feel ye to kuch to forgery wala hai. He is not giving all information. Clear? So every detail you write down here. So this is about experimental. So you see the heading. What was the heading here? Experimental details and procedure. So what we have taken everything, and what is the procedure? Procedure means here you see micropump giving a fluid to the test section, flowing through a flow meter. Test section it is heated, pressure temperature measured using transducer. Again it is condensed using a condenser. It goes to a constant temperature bath, maintain that same temperature. Again it goes. So it goes a circular loop. This is the procedure. After that, I told you it is also contains the numerical modeling, experiment plus numerical. So again, under M, again comes another heading, that is numerical. So simulation details will be given. And when you report a simulation details, you see here, the schematic representation of the computational domain is given here. And in a simulation, one standard is that nowadays, you have to give grid independence test and model validation. Okay. So these things are very standard nowadays. So that time it was not mandatory. So this is not there in my paper. But today, if I will submit same paper, they will say you show the grid independent test and model validation. That time very limited people used to do simulation. Nowadays, frequently people are using simulation. So they do not believe you. Competition is going now. They do any mess and they report the result. That's why they want grid independent test results here. So that you report. Okay. Then comes your results and discussion. So result discussion, it is a combination of both experiment and simulation. So a single plot can be purely experiment, purely simulation, or a combination of both depending on your situation. You are free to decide. So there is no guidelines for how to describe result and discussion. It is your own creativity. You can use contour diagram like in your previous paper you might have seen, or you have only simple line diagram. So here you see these dots are experiment, and here you see this line is the simulation, and these thin lines are the linear fit. So they are overlapping. So I am saying simulation is matching with the experiment. This way you have to defend your work. Again, at the end of the this section, you will have final again summary and conclusion. After that, again acknowledgement, then references. Clear? Okay. Now we will go for a purely 100% numerical simulation work here. So overall, it is again same: abstract, keywords, introduction, and your nomenclature, literature review. Then comes your sorry, I opened same file only. Oh, sorry. So this is a purely numerical simulation work. You see here title, author details, again abstract, keywords, introduction, which contains the literature review. Again, I have not written it separately, a literature review section. Okay, and here towards the end, again the conclusion from the literature review. If you see here, my work is simulation, but literature review will contain all type of work. It will not be only simulation. It can be experiment, mathematical, because you are just explaining what development have taken in that field using any method. Although a number of numerical means this paper reported numerical work and experimental, this paper's reported experimental work have been done. Effect of this and this is not available. This is the conclusion. And since it is not available, I am motivated to explore it. So I did this study. So that's why here you write, in view of this, a simulation is undertaken. So here, then what we do, we have explained here. So in view of this, we have carried out a 3D simulation with variation of these parameters. So these things are written. Reynolds number varied from this one, thickness this one, like that. Okay. Then comes your numerical analysis. That is, this is your M now here. Method. So it is a numerical method. So in numerical methods here you see, first you will show the computational domain. So this is the computational domain through a schematic diagram. Okay. Then the governing differential equation and the boundary conditions you are going to solve here. Then here you will have a grid independence test. This is your grid independence test. You see here different grids you have reported here. So sometimes you can write as a separate subsection, or you can write as a part of the section itself without a separate heading. Each choice is yours. So here I have written grid independence section as a subheading. Then your model validation. Actually, model validation I have embedded here only. You see, different other work are there. So I say there is a matching. That's why model is also validated. Otherwise, you can have a separate subsection as a model validation also. After that comes your again result and discussion. So again, you are free to have any of these papers here. But here you observe this paper. Here there are 9 graphs are there, but this is considered as one figure. This is considered as one figure. Okay. So now I have to apply my own creativity. Should I arrange as given here, or should I have taken one below one like that? What is taken here? For example, this one. If I have to take this one 9, you just imagine how much space I need. I will have only 2 on one page. Here 1, 2. And in a single page only you will get 4 only. 2, 2, 4. 1, 1, 1, 1. Or maximum maybe 3, 3. That means you require a lot of space. There is a page limit also there here. In this article itself, I have been asked to deposit $400. I made a request, I cannot pay, I am a student, though that's why they made it free for me. So that's why it is your also responsibility to make the manuscript smaller without compromising the quality or the loss of information. Clear? So here you see when there are 9 figures are there in a single figure, how to identify individual one. So that's why inside you will write down again sub number, like you say here, A, B, C, D, E, F, G, H, I. So that means it is 3A, 3B, 3C, like this you will refer in the description. So you can see here, figure 7A, figure 7B, description, like that. Okay. Then here you can see this, okay, you tell me, this figure is, what is the width? 9, maximum 9. This figure was maximum 9. And this is maximum 19. I prepared maximum 19. And this one 15. This one 15. Okay. This I cannot accommodate it 9. Impossible. That's why I had no other option to go more than 9. And that's why I accommodated in 15. Because you see, this is a half of this width only. I cannot make it very small also. Nothing will be visible. Okay. Again, here you see, this is also comes under 15 only. Some white space here, some white space here. But again, here there are 6 figures are there. If you closely observe for some time, you can see they are exactly at the same level here. And this gap are same also. So these are called aesthetic beauty. If not same, they will not reject your paper, but you should make an attempt to make it same to look your figure also reasonably good. This is also important. Then whatever the font inside the figure should be reasonably matching the font with the side text. For example, you see, if I zoom to 150 or 170, if I am able to read this text means I should be also able to read this text. So that also you should keep in mind while creating the figures. ऐसा ना हो कि you cannot read what is written inside the figure. That is not called a good figure. So these things also you have to keep in mind. So next we will learn how to create this single figure out of separate 6 figures. This is also not a easy task. Creating good quality diagram is a art and it is the need and you should learn it. Obviously, it is very time taking. Very time taking. I said now you see everything you see. For making a simple one slide only, it takes 1 hour. One slide, it takes 1 hour.
For 1 hour, especially.
That is important. That is important. That's why you see, you should make it perfect so that the reader will find it or struggle it to find error in your work. That is important. That is, you see, this is not being seen anywhere around here. It is seen by across the globe. So it will represent your impression also. Suppose I read 10 articles from Africa, one country, and I find all their figures are bad. So what will be my impression? These fellows are not very good in diagram. That's why I said engineering, drawing is the language of engineers. That's why every branch of engineering are taught drawing. I do not know computer science is being taught drawing or not. Is there anybody computer science student here? Oh yeah, computer science. Have you read engineering drawing? Okay, very good.
Yes, sir. Yes, sir.
Huh? First year.
In our graduation, we
Shifted from manual to computer, so we do not learn anything. You have read in first year. Okay, very good. So that graphics, it should not be graphic. It should be pen and paper based, because if you do not understand how much is 3 centimeter, Can somebody tell how much is 3 centimeter approximately you saw physical distance? That you should have idea. You will say this is 3 centimeter. That means your engineering knowledge is not 0, minus 20. Okay, so you should be able to tell 1 meter means this is 1 meter. Okay, this is 1 meter. 30 centimeter means this is 30 centimeter. You should be able to tell. Otherwise, you are not an engineer. Clear? Okay. So that's why I told you drawing is very important. I have requested one of our faculty members also to give a 1 hour class drawing for engineers. I am hopeful that a class will be organized because he is away from campus because of his father's illness, and we expect he will reach tomorrow here. Then we will have a talk on Wednesday drawing. Okay. So any doubt regarding these structures here? Otherwise, next we will go how to create these quality diagrams. Okay, fine. So we covered about writing a journal paper as a full research article or as a review article. Okay. Hmm.
Which topic is the correct one? Both the topics the correct one. पेपर तो चार्ट का चार बन जाएगा, जब फाइनली फाइनल रिसर्च पेपर बनाएंगे, ओरिजिनल रिसर्च पेपर वो किसमें करेंगे, ये सिलेक्शन कैसे क्यों करेंगे?
That means your research topic deciding. I told you always you should select a emerging topic. What do you mean by emerging? Emerging means research started just now in this direction. For example, artificial intelligence and machine learning is a new topic. That's why if you are expert in AI ML, companies are there, they will give you crores of salaries now. But you should be expert. If you are semi-expert, you expect lakhs. If you are zero expert, you expect zero salary. Okay. Because AI ML being applied into many fields. Recently, I found AI ML in CFD. So I am expert in CFD, but I do not know what is AI ML. So recently, I started thinking that I should also learn AI ML. Earlier, I was having impression AI ML is for computer science. I've seen few articles AI ML in CFD. I read these papers. I could not understand what they want to tell. Maybe because I do not know what is AIML. So I have to first learn what is AIML. Then probably I will be able to understand why what these papers want to tell. But what I believe, if I write a paper today with AIML CFD, immediately it will be accepted. That means whatever the जो जमाना चल रहा है आपको उसके पीछे चलना है. Now it is going for online business. So you should go for online business. ऐसा नहीं कि वो पान का दुकान घर के पास अभी नहीं चलेगा. You have to make कि ऐप बना बैठा हूँ आपके घर में जाके पान देख आएंगे. That will run a business. Home delivery of pan, but not pan shop will run. Traditional one. So this innovation. So this is an emerging one. तो अगर आपको पान दुकान लगाना है तो ऐसा करो कि होम डिलीवरी पान. That you have to do. Not only देसी पान दुकान. So like this. That's it called emerging topic. Again, how to understand emerging topic means this requires little bit time, advice of experts, and some common sense. Again, there are two emerging topics. Which one I will select? So my best advice is you take a ant, वो दो emerging topic को इधर रखो और ant को इधर छोड़ दो, and you decide to see after you close your eyes. बाद में देखो कि हाँ इधर खड़ा है तो इसको select कर दो. You do ना this or this. इसको पकड़ो इसको पकड़ो इसको पकड़ो. अभी कुछ भी नहीं होता है. मतलब why I hold this? No logic. तो फिर कोई अगर लॉजिक नहीं है तो random. That is called random. In computer science, it is called random. Otherwise, you apply your brain, both are emerging, but which is likely to run for longer time. Sometimes it comes emerging but dies immediately, like pager technology. Before people could understand what is pager, the technology died. Hopefully, most of you will not understand what is pager also. But it was a very hot for small time, maybe 1 year or so only. They were saying one SMS will come whenever you are running in the road. Now everyone is getting SMS when running in the road. That's why that pager device, the technology lost its relevance. So if you do business, if you have a plan to do business because it is emerging, then you lost. So that also you have to think. Emerging but long run. That also you have to see. Okay, so before preparing quality diagrams, first we should have plots. Like as I told you here, without plots, how we will think for combining plots? So first let's learn how to create the plots. Okay. So what are the types of plot? The first one and simple one is called your line plots. All these are called line plots. So this is a line plot, this is a line plot, this is a line plot. Okay, they are different in look, but all are called the line plots only. Okay, so this is a line plot, this is a line plot. Then you have another type of plot that is called your contour plot. For example, you see here, this is a line plot again, but this is a contour plot. This is a contour plot in the form of lines, not a form of colors. Mostly contours is good to represent in colors, but again one problem is there when you give a color photo, color figure here in the manuscript, they will ask you for money because they are also printing in hard copy in addition to soft copy. So now they give an option, you want color in hard copy or not. Color in soft copy is free of cost because they do not have to give an extra money. So if you opt color in hard copy, you have to pay money. But if it is a color figure, if you take printout, normally we read this in a black and white printout, journal papers. So information will be lost. So better you create a black and white photo, and it will not just convert to black and white, because if there is a red, green, blue is there, if you convert to black and white, how will I will understand the difference between red, green, blue? So you apply your brain and you think how to change that one into a black and white figure. So you should make it yourself, then you give and you print now color, because black color everywhere black means it is a single color, so it is a free of cost. So this is a contour diagram. To avoid this charges, I created in a black and white form through this. This is called isothermal lines now. This is called isothermal lines here in our language. Okay. This is a line plot. But you see here inside the line plot, I require to represent something explained. So I embedded this figure here inside the plot. So this also you need to learn how to create something inside a plot. This feature will not be available in softwares. Most of the you have to do somehow manage it. जुगाड़ technology लगाना है. Okay. Then this paper you see here you have these are line plots and this is a contour diagram. Okay. These are contour diagrams. So I could not find how to represent them in black and white. I struggled. So I told that, okay, you make it color in soft copy, black and white in hard copy. Whoever prints in black and white, to understand better, he will also refer to the soft copy simultaneously along with the hard copy. Okay, so this is your contour diagram. So this contour diagrams, how you create is that that cannot be part of this course because it requires a lot of time, but simply I will explain. In many cases, you will get it as the output of your software if you are using some software, or you can use some specialized software also, you create these diagrams. But for example, here you can see after getting these contours out of the software, it requires some extra processing also. Like here you can see in this diagram, I need to tell this is the value 2a, this is the value 1.5a. This you will not get in the software. After getting this color, I have added it extra. Okay, and here a, r, theta, this is for explanation, not mandatory. To make it better explanation, what I want to tell, I have drawn. Again, you see there is a dotted circle is there. To tell that it is the average of the minimum and the maximum radius. in the waviness on the outer boundary. Okay, so like this, you may need to do some editing inside the plots also many times. Okay, so first we will see how to do the simple plots here. The simplest way to start a simple plot is to start using Excel. And for your data management, I always recommend using the Excel. Excel is good for data management, but I do not recommend for using the plots. However, we will start from Excel only. So for 2D plots, we need 2-column data, X column, Y column data. Let's say I will create some imaginary data. So I select X and Y column, then insert. Here I go chart. I plotted here. Okay. But what is x-axis value? What is y-axis value? Everything I need to tell. Okay. And suppose I have 2 plots are there in a single one. Then I will have again so this is your my xy. This is another xy. Suppose I want to say this is experimental and this is your numerical. We want to compare this value. Okay. So I want both plots here. That means I have to embed the second plot here. I will go here, select data, add series name. This is a numerical, x value, this one, y value, this one, then okay, okay. Then series one, I will edit it. Series name is experimental. Okay, so after doing something, I manage the plot. Now I need to write what is x direction or what is y. Suppose x direction is distance, y is suppose speed. So I need to write it here. So here I go. I write here legend, then axis title. Okay. So here I write here distance vector. Okay. Suppose here I write suppose I write acceleration. Somebody remember what is the unit of acceleration? Meter per second square. Very good. Meter per second square. Okay. But if you closely observe here, I am struggling a bit to write second square. It becomes S2. I need a superscript. Okay. So here one difficulty I am facing. First point here. Second thing you see here. Okay. Finally the plot is ready. This I will write suppose distance versus acceleration plot. Plot is ready. I can save the file. I can keep it. I can edit anytime. But I need to write a journal paper. So I need to copy this to a Word file. So right click, copy. I will open a Word file. I pasted here. I do not know what is the size of this plot also, because we have some condition 9, sorry, not 15, I did a mistake, it is 14, now I remember it, 9, 14, 19, 3 sizes are there. Okay, if it is less than 9, we will make it 9, or around that. 14 means around 14 or around 19, 3. I do not know what is the size. Okay. And should I make it small like this forcefully, or should I make it large like this, or should I pull here, or should I pull here? So whatever operation I did, the shape is changing, size is changing. So whatever I did, everything is illegal. Of course, police will not come, but it is not good, I can say. Okay. Sorry. This is the original paste. Control C, Control V I did. Next, I will create the same plot. You see how the new plot is and how effort I require to do that same plot. Okay. I say data management in Excel only. So I have kept the data in Excel. I will copy them now from here. I am using another software, Origin. Try to recall after creating this imaginary data, how much effort I gave to create this plot. That you recall. Okay. So I opened it. I click here. Okay. I got something similar to Excel sheet. Columns are getting, but I need 3 columns. It is there 2 columns only. Sorry, I need 4 columns. XY, XY. So right click, add new column. Right click, add a new column. It says AX, BY, CY, DY. That means it says first column is X value, remaining are Y value. But I have XY, XY. So what I will do is I will right click here. I will set as X here. So it becomes XY, XY. Now it is there in my memory. I pasted here. Then I selected 4 cells. Then here I go. I select this one. My plot is ready here. Then here you see what I'm doing here. Uh, sorry. So just check me. First one is your blue one is experimental. Okay, other one is numerical. So red is numerical here. Sorry. You see, I got the plot here, and huh? Huh? And that is curved. Okay. So here also the all options are there. Okay. Let me make it landscape so that I will try to keep this one on its side so that you can understand the difference between them. So which one you like, left one or right one? Huh? You like right one, everyone? How many like left one? Please raise your hands. Okay, nobody. So this is what I want to demonstrate, that it is the same plot, but different software will give you different quality. Clear? Here if you see, a lot of features are there. I also everything you can do here. I think I know only 5% of its features only. I have never got time to explore also. Many things are there here. So, and software is self-learning. You give some time, you can learn it here. There are a lot of controls are there here in the software. For example, different types of symbols you can select here. You see, sorry, this is symbol. Big list is there. And you can change the size here, your colors you can select, many things are there, lot of controls are there here in the software. Okay, so it is important, same information how you present. So I personally recommend using Origin software. However, Origin is a paid software, but for our NIT Rourkela campus, our students it is free. We have purchased it. NIT pays money for it. Okay, and for others you need to consult your institute and motivate them to purchase this. And no, data management also done there, but I personally recommend Excel only. You save every data in Excel and take it to Origin and plot it. Clear? And here you save it, file save project. It will save its own format. Extension is OPJU. Okay, suppose I write it is 2D plot. Okay. OPJU, its own format. That means it can read by the software itself. Okay. So they do not want that key. It should be available. Origin is paid software. Origin is paid software. If you save it in own format, you can open it. You can edit it anytime. Okay, this is the figure is there. Here is your plot is there. Even you can have multiple plots also in a single file also. Multiple plots also you can have here. Okay, lot of features are there. You need to explore here. I am just going to explain what are the basic requirements you should learn here to make a good research article. Everything is there. Contour diagram, everything is there. Whatever related to plotting, variety of plots, everything is there. I told you na, I think I have explored only 1 or 2% of this every feature. Everything is not required for you also. You will need only some specialized things out of this. For example, suppose you want to calculate what is the area under this curve. It is simple here. You go to analysis, mathematics, integrate. You make it okay. It will tell you area under the curve 191. Okay. So this feature also used. For example, you know, in one of my paper, there was a plot like this: Nusselt number versus Z. I want average Nusselt number value. So how to calculate average Nusselt number? Area under the curve divided by the width of the domain. So width multiplied by height is the area. So area under this curve is equal to a rectangular area, where the height of the rectangle is the average value, because the length for rectangle and the curve are same. So using this feature, I calculate average value. But software does not say that this can calculate average Nusselt number for your plot. You have to apply your creativity and use the concept. And here you see how easily I am able to write the superscript here. Suppose you need to write here something, some symbol. So what I will do here, you see buttons are there. I will write here. This is alpha. So I am able to introduce a symbol. So I am to write alpha power 2. Okay. Suppose I have to write something a2 square. That also I can write here. Here 2. Suppose, sorry, a1 square I am writing. So a1 square. So these things you cannot do there. Okay. You can position it wherever you like. If you want, you can remove the border also. Just right click, you go to properties. You can remove the borders. You can do every lot of controls are there here. Okay. That is a very important question. So this is what I am going to teach you here now. Okay. I do not know what is option is there or not. I devised my own method. I adopt it. Okay. Suppose this is the perfect figure for me. So my personal suggestion is here where you should position it. There is no official rule, but your objective is that same information looking better. If you ask somebody, they say a very good plot. That should be the comment you should receive. So you see, I can keep it here also. Okay, or I can keep it here also. But what I recommend is you keep somewhere in a corner where it is free, relatively free. So this corner, this corner, this corner, here you see this corner is relatively free. So you put in this corner. Now question is how much away from vertical and horizontally? A small distance, but you should make this and this equal. Then aesthetically it will look good. Otherwise, if you keep here, or maybe keep here, or maybe you keep here, it will not look good. Okay. And how to measure the distance? Nobody will check with a microscope, just to use your hand skill only. Okay, you observe. If you feel slightly left, so do not use the mouse for small movement. Use your left right key. Okay, by clicking there, slightly left up down, you can use your left right up down key. You can position, and you see if you are satisfied, you leave it. Clear? Okay, figure is ready. Then now we will save it. If you press save here, then it saves its own format. We do not need this. We need a image format. So here you go. If you are going to prepare a PowerPoint, what you can do, right click, copy paste, then you go to the PowerPoint and here paste here. Okay. The advantage here, it creates a transparent plot. वो आपका पेज नहीं दिखेगा. Suppose I will paste this one in a colorful page. Let's say suppose here. It is transparent. So background will be visible, this plot will be visible. So most of the cases we need this one to make it looking good. However, here background is bad, that's why it is not looking good. Okay. Otherwise, if I will put a image here, that person will become white. That will not look good. Okay. So for PowerPoint, you can do this way. Even here, lot of controls are also there. You can make it bigger or smaller as per your convenience. But when you make it big or small, it should be shift and move diagonally. Uniformly, it will increase. You see, uniformly increasing. Scale will be same. Aspect ratio maintained. Otherwise, what will happen? Its aspect ratio will change here. Clear? Okay. Then here sizing means you do sizing by hand here as per your requirement in the slides. And I recommend in a slide you use maximum 4 this type of plots. The maximum 4 means one here. Let me use a blank sheet. One here, another one here, one here, and one here. Again, you need to precisely position them also. Okay. Then important thing, just I kept it roughly. I have not applied detailed brain, but to make it better appealing, you should go into macro details to make it good. Like what is to make it good? This upper line should lie in a single line. How to do? Simply you take a line here. Okay, you draw one line. If you feel let's say make first, let me position one correctly, then this one I assume this is now positioned correctly. So you see here it overlaps on this line here. So this is my reference here. So what I can do, I can change its position to make the reference now here. So now both are on the same line. I will remove this line now. Clear? Then I want they are aligned. So again you take another line. Actually my hand was there, that's why it is there. Okay, then again here you take same, it is not there, again you use the left. For small positioning, do not use mouse unless your hand is so skilled. You use left, right, up, down key, and once you are satisfied they are okay, you remove this reference line. So this should be the okay. Another important thing, any mistake you find in this slide. Now you see this white space and this white space are not equal. So you should try to make it equal. Okay. So how to do it? Any suggestion? Simple. What I do, I create one box here. Okay. ये दोनों को select किया, दोनों को equal ले गया हम. I kept it here. Then I will take this box here, and I will take these two together, and I will bring it to this level. Then you remove this one. So now it will look equal spacing. So these things nowhere written, nobody taught me. I applied my own brain and I thought this procedure. Clear? And feature there how to make both at same level. Here inbuilt feature is there, here and here. You see here arrange, align top. So actually it was not at same level. So now they become at same level. Inbuilt some features are also there. Okay. So if you ever observed my slides in detail, you will see you see how they are same line. It is not a single one. They are different maybe wherever you get this one. So that feature I used and I created alignment. So lot of things are there here. Arrangements, align left, right, top, bottom. Lot of features are there. So you need to use these features in your slides. Clear? Okay. And this was all about taking this plots into slides. Next is taking the plots into your manuscript. We need a image form. So here it's now already I have saved it. First you remember to save it. Okay, it is saved in its own format. Anytime I can open, anytime I can edit as per my requirement. So now you go file, you go to export, graph. You got this window here. It says what format of image you need. It says EPS by default. Suppose I will say a TIFF file. And what is the file name I will give you? I will give you, let's say, 2D plot. And where I want to store it, suppose I want to store it, let's say, at the desktop. Okay. And then here export settings are there. Image sizes, everything is there. Okay. So what you do here, it says fit width. It is auto means automatically some value came. So you remove this auto. So now you have the option to decide the width. You decide what unit you will give. If you want to decide in terms of pixel or in terms of dimensions, everything you decide here. Suppose whether you want to decide the width or height. So in our manuscript preparation, our important is on width because there is no restriction on height. Only one restriction is the height of the A4 sheet. Okay, but width we have restriction either 9 or 14 or 19. That's why here you will select the width only, and automatically whatever heights comes for that particular figure does not matter. But it should not exceed the maximum height. Okay. Then here you see image setting is there. DPI resolution. This will decide the quality of your image. Always please note down all your images should maintain minimum 300 DPI. Minimum 300, and the higher you take the better, but higher DPI means more memory will require, more bigger file size will become. Okay. So minimum you should maintain 300 here, and it says whether you want color or you want to convert your color plot into black and white. So if you need a black and white plot, here you can change from color to black and white. Otherwise you can have whatever default is color only. And suppose here I will decide width centimeter. How much we need? 9 centimeter. Yes. Okay, I will write here 9. Fine. It is a 2D plot. The name is 2D plot. TIFF file. Location is desktop. 9 centimeter width. Color 1. Okay. Then you press apply. We will go to the desktop. We will see. Okay, the file is ready here. Fine. Now we are happy. So what we will do? We will copy this from here and we will put in our manuscript. But now question arises whether it is 9 or not. How to ensure? How to ensure whether it is 9 or not? So you right click, format picture. You go here. Here it is not giving the dimension. Width is 9, height is 6.88. But there is a big problem is also there. Width is 9, it is including left and right white space. So this left and right white space that we does not require. So 9 is the canvas size, not the plot size. What is canvas? Canvas is the background. Clear? We need a 9 width picture, not canvas. Canvas can be bigger. We can crop the canvas. Our picture should be 9. Clear? So whatever we did is wrong. That's why what you have to do, now you apply your own logic. probably the software makers may not have thought this one, they might have some other logic, but I found my way to do this one. How I do this one is, from experience, I know that if I put 9, I will get less than 9. So I need some higher value so that after cropping white space, I will get 9. Now question is, what is the value? So this is a intelligent guess. It cannot be 2000. It will somewhere maybe 11, 13, 14, 15, some value in that range. So I look it for fraction of second, then immediately one value comes to my mind, then I give that value here. File, export. Here, sorry, it is, I will make it CM now. I will remove auto. I will make, let's say, 14. Okay. Again, everything new setting required, old gone. Again, TIFF file. Again, file name is 2D plot. Let's say I will write 2 here. I do not want that to be overwritten. That file also will keep it to check. Okay. Then here 300 dpi is there. Fine. I made it 14. Okay. And then location is again desktop. Then again I will apply. Close. Okay. So 2D plot 2, it is there. Control C. Again here. Control V. You see, now I get 14. So I got obviously bigger value. Okay. So I need to crop it now. So here I am doing manual cropping here. So this should be now 9. But how to know this is 9 or not? Again a big challenge. Okay. So again use little with your common sense. Here there is a option. Last one. This is the new one. This was the old one. So old one was 9. Big one I took 14. I cropped it. Okay. Cropped one is bigger than 9. So from here, if you compare this one, I can say it is now bigger than 9. Applying common sense. Okay. That means 14 was not a correct guess. But let's authenticate in another way. How to do? Here you will go here. Some scale somewhere it comes ना. इसमें scale कहाँ आता है? View में आता है scale. Where is view? View Ruler. Okay, ruler. You switch that. Okay. You see. Hello. Here you see, it is coming to be 11 centimeter. So I took 14, I got 11. I took 9, I am getting it. If you start somewhere here, suppose I crop it. I took 9, I got 7. Approximately I am telling, okay. And I took 14, I got 11. So now you find a formula. Okay. What should I take so that I will get 9? Otherwise, you make again one more attempt. So instead of 14, I will take, let's say 11.3. Okay, let's try with 11.3. Okay. So you see 11.3 I got here. Now we will crop it here. I got 9 here. Okay. It's not perfect 9. From look, I can say it is around 9. Okay. If you want to know exact value, you come here. It says 8.9. Okay. So it is okay. By handset, I got it 8.9. If you want to make it perfect 9, what you can do here is there is option to change the size by maintaining the aspect ratio. You make with 9, it will make 9. So micro adjustment. Only I increase 1 mm length. Otherwise, this is also okay, no problem. Clear? So this means I got. So why I took 11.3, why not 11? This is from my experience. I am using it for since long time. So if you use it for long time, what is written there, that is also important. There you will get an idea that how much value you take, you will get 9 value. So otherwise some hit and trial, you will get a value, that one. Suppose you got 8.9, then you try with again 11 point. Then I did the cropping by hand. So there also I can increase or decrease 1 mm also. Clear? Okay. But to make it perfect to the micron size, where it is required when you have multiple figures in a single plot. I said 3 by 3. That means I need everything to be exactly same. So how I will do cropping there? Not this manual cropping. There we will adopt. Here you see here. Its crop feature here we will use here. इसका क्रॉप कहाँ से होता है? I think this doesn't have a crop feature. Open with photos. इसमें होता है क्रॉपिंग. I forgot. और कुछ कॉम्प्लिकेटेड आया इसमें. I think Paint 3D में होता है. Crop is there. Okay. Fine. No. Is there na to see photos in Microsoft Office? I forgot. There is option. You can set the values and you can crop it. I forgot. Picture manager. How to get that one? Achha, choose another app. Picture manager. That it. More app. Where is that more app? Down. Oh. Microsoft Picture Manager. ठीक है, इसमें ढूंढते हैं ना Microsoft Picture Manager. I think they have removed it now. Okay, fine. There is other ways also there. So there you can do the control. For example, you have 9 plots. So what you do, you write in the first plot how much you cropped on left hand side in terms of pixel or distance value. You do the cropping same value in every plot, or otherwise it should be sum of left and right cropping value equal in every plot. इसका लेफ्ट में थोड़ा ज्यादा है, उसका थोड़ा कम है, लेकिन इसका लेफ्ट में ज्यादा है तो उसका राइट में ज्यादा है. So some should be same, so that the width of remaining part should be same in every figure. Similarly, the height of the figure should remain same in every figure. This way you ensure that you created 9 figures and every figure is exactly of same size in width and height, perfect in micron size also. Clear? Okay. Then next we will try to combine them. So for that I use a software called Adobe Photoshop, which is a little bit expert software. But somehow I am using it, so I do not have any other option to explain you in that software only. This is normally used by photo studio people to create your carbon copy or your color copy along with yourself. Okay, and anything, whatever you like, they can do it nowadays. So I have opened it. Go to new. It will create what we call as the canvas. And now you decide the size of the canvas here. So what I will do, first I will show here how to crop that figure using this feature. I will say width 9 centimeter and height I am written some random value here. Okay. And here you see I got the canvas. Now I will bring that plot into the software. So I will say file, open. I'll go to the desktop. I will the latest plot I will bring in here. So it is a separate one. It is not open inside the canvas. Please remember. This is the canvas. This is the plot. And I need both side by side. So what I will do, now I select Control A. So everything is selected here. Now I take the mouse here. ये क्या हो गया अभी? This version is little different. Then press your control. I embedded it here. ये तो आया है, लेकिन क्या आया? Okay. I got this view. I think here I failed to define the DPI probably. Let me check. File new. Okay, so I have to tell it this to be 300 pixels per inch, 300 DPI. By default it was 72. Okay, I have done it this one now here. So next I will say Control A. Sorry, this one. So now see, I created a canvas. Width is 9 centimeter. Height some random value I have taken. I have not bothered here because my interest is on the width only. Then this figure I have inserted into this canvas. Earlier the mistake was that was in 72 DPI, 9 centimeter, and the figure was in 300 DPI, 9 centimeter. The physical size will be different, so they were not matching. Now you see, I brought the figure here, and here background is your canvas. Now I am having my figure here, so you can see here when I am moving, you see to the left and right of the original figure, your white parts are there. Okay, but whatever you are seeing inside the canvas is exactly 9 centimeter. And here layer is there, you see. I can switch up the layer, switch on the layer. Okay, along with the background. Next here, what I can do, I will merge the layer here, merge down. Now my figure become 9 width only, perfect 9. I want the height to be cropped now. So I can do the cropping here. This cropping I can do by hand. Okay. So this image is perfectly 9 centimeter width, and I do not know what is the height. And we can check also file. We will save it. Export as. Hey, Sobhyaji, how to save here in this version? Export or what? Okay, this one only, export only. Direct save होगा था ना? Actually, I am new to this version. File save, where is save? Save as. Okay, save as. Here you decide PSD is the Photoshop document, its own format. If you have multiple layers, you should always save in PSD because later on you can edit them. Okay. If nothing to be edited in future, you can merge the layers here. So you might have observed I merged the canvas with the photo. That means this is the canvas and this is the plot. I merged them together. I told that it is a single one only. Okay. And when you are editing, making a complicated one, all the layers should be there. You should save it in PSD. Again, you duplicate the file. You open it. Again, you merge the layers so that you use it for your as a image format. TIFF or JPG, whatever required there. So here, suppose I will make it a TIFF here. Suppose I write here 2D plot version 4 here now. I save on desktop. Okay. Then I close this one. So 2D plot version 4, this one. So this is you see now. No white space extra is there. Perfect 9 in width. Height I do not know because we are not bothered about the height at this moment here. So when you are doing it for multiple figures, you should bother about the height. That you can also know from the software there. For every other figure also you do this way. And suppose here I will assume I have created 9 such figures here. Here I did one small mistake. We are going to create one single figure. This is the canvas. This canvas will contain 9 plots. 1 plot, 2 plot, 3 plot, 4 plot, 5 plot, 6 plot, 7, 8, and 9 plot. And this width is how much? 19. Clear? This height does not matter. So that means roughly so what this dotted line indicate? This is one figure just now I created. So like this I need 9 figures. Okay. So if I need 3 figures to be placed 19 means one width should be 19 by 3. Okay. I did a mistake. I created a 9 centimeter. I should have done 6.34. Okay. No problem. So now I will explain you if this is 27 centimeter width, how I will create this one. But you will require to do for 19 only. So you will create a 6.33 size figure. Clear? That's what you might have seen. In that figure, pictures were little bit small. Not the same as the single width figure. So Now here you see whatever this become is the single width figure. So now if you go to the software, uh, uh, I will take 5 minutes only. Na? That's why saying na, if everything is perfect, it will take less time. So we'll go new. I will make here 27 for the demonstration. And height I do not know. Maybe I will write, let's say 30 or let's say 35. I'm writing. Okay. And then okay. And this is your sorry. Pixel. 300. Okay. Then file, open, desktop. Okay. So like this, you will read all the 9 images and you will keep one by one. So the first one will be figure A, figure B, figure C, D, E, F, G, H, I, or A, B, C, D, E, F, G, H, I. Whatever the order you have decided, you keep in mind accordingly. You keep them arranging inside the canvas. Okay. So this is the figure, one figure. So like this, you have 9 figures here. You have to take all figures and you put in the canvas. So here I am taking the same figure 9 times. But you have to remember, you will have 9 different figures. You will take one figure once only. So you see how a big figure become very small. Actually, figure not become small. Here, if you click, its zoom is 66.7%. If you click here, and this zoom is how much? 12.5%. If you make this to be 66.7, it will become same size. But I need to see the full one, so it will become smaller one. Okay. And now you see what I will do is, I will keep it here. One again, I will click here. I will take another one. Again, I will click here. I will take another one. Okay. Let's close it. So I got all the 9 figures. There some feature is there. Through your hand manipulation, you can keep it side by side perfectly. But now I have to ensure they are on the same line. So use the same principle. You take a temporary line, बाकी को adjust करो. So here there is option to take a temporary line here. Oh, line कहाँ गया? अरे line कहाँ है? सब से जी. This one, line tool. I draw one line here. So you see, all our layers are here. If you switch off a layer, it comes out. It is like transparent sheets placed one above another. Okay. Now you go to zoom in here. Oh, you have to increase the thickness of the line. Then you right click, layer 2, you adjust this one. Right click, layer 3, you adjust this one. Then you right click this one here. Again, you bring this line to different position. Again, you align, bring to different position. Again, you align. Okay. But again, you have to ensure that this gap and this gap are same. So again, you take a rectangle. The way I have taken here. So you keep this rectangle here. Okay. After same size rectangle, again you take this rectangle here, again you adjust this all three together up. Once it is done, again you crop the remaining area, you merge them, again you save it, it will become a single file with 9 figures. Clear? So this is a new software, you will require little bit understanding. So I think presently I am using version what I collected in 2006 or 8. So this is a new version, but overall it seems to be same only. Adobe Photoshop. This is a very costly software, very costly. Somehow I managed to use it, but its free equivalent softwares are available. So just go to Google, you type. You see, every costly software has its free equivalent. Okay, you just type here. Adobe alternate free software. So lots of there. GIMP is a good software. Pixel, lots are there. So these features will be definitely there. So you explore them. Clear, and you save them as a image file, whether TIFF, JPG, whatever you require. Let's work. So if I will save this one here now, suppose let's say I have not drawn the cropping etc. Okay, let's say file. I will merge everything here. Merge visible file, export, save as. TIFF is there. You see, I got a single file here. Okay. Then you copy it and put in your manuscript. That's all. Okay, thank you all for today. I am a little bit hurried today. I have a talk again at 7 somewhere. I have to run from here. Also, I do not have my bike with me. I have to go to my homework and I have to run. Okay, thank you all. If you have any query, we will take up tomorrow morning. So again, please be there by 8:55 so that we can start at 9 right time. Thank you all. Thank you.